Hello everyone. So in today's video, what I want to look at is how we can graph lines, so a review from grade 9. And there's really two main methods that I want to focus on in this video that we may use throughout grade 10. The first is to remember that how we make a table of values. So if I have the equation of a line, remember the equation of a line is going to have two variables, an x and a y in it, representing our two Cartesian axes here, our x-axis and our y-axis. So if I want to make a table of values, also sometimes called a t-chart, okay, we're going to make two columns. The left-hand side is for our x values, or our x coordinates, and then the right-hand side will be for our y values, or our y coordinates. We can pick whatever x values we want to put in here. Remember that we are graphing. On the graph I've provided here, I'm only going from 6 to -6, so I want to pick values that are relatively small. So usually what I will do is something like this here, 2, 1, 0, -1, and -2. So I'm going to pick 5 values. And then we're going to calculate our y values. And we calculate those y values by using this equation. This equation is giving us a relationship between the x and the y value. So we're trying to figure out that when x is 2, and I calculate that, what would the corresponding y value be? For the first one, I'll write out the calculation. So something like this here, I'm going to do a substitution, -2 in place of the x. I'm going to put in 2 plus 3. So then we can calculate our y value, again, either mentally or if you need to use a calculator, that's fine. -4 plus 3 tells us that this is -1. I'll do the same thing then with 1. What happens when I put 1 into this equation? -2 times 1 plus 3 equals, calculating gives us -2, plus 3 gives us a value of +1. If I sub in 0, well, this is up to you. Do you want to keep writing out the whole equation or not? One option is just to do this now mentally. If I put 0 in here, -2 times 0 would be 0, plus 3 is 3. What happens when I put -1 in here? We need to be really careful with these negatives. -2 times -1 would be +2, plus 3 more is 5. If that's too much work to do all mentally, then you can go back and you can write out the calculation in full for each of these to show the calculation to come up with that value. So I'm showing you both ways, and you're welcome to do whichever one you want. Lastly, if I sub in -2 here, -2 times -2 would give us +4, plus 3 more would give us 7. Reminder then, what we have done here is we have generated 5 ordered pairs, okay, for our graph. If I was to write this first one as an ordered pair, remember in brackets I would put the x coordinate first and I would put the y coordinate second. So there is our ordered pair, 2, -1. The second one would have an ordered pair of 1, 1. The next one would have an ordered pair of 0, 3. Next one would have an ordered pair of -1, 5. Last one would have an ordered pair of -2, 7. So what we're doing is we're plotting these points then on our graph. Okay, remember that our x-coordinate, our x-axis is our horizontal axis, so this is saying to go to +2, and y value is -1, so there's our first value. When x is 1, y is also 1, so there is our next point on the graph. When x is 0, so I'm not moving left or right at all, my y-coordinate is 3, so there it is. My next point, when x is -1, y is 5. There is that point there. And my last one, -2 and 7, happens to be just off the graph. I'm going to put it on here anyway, but we already have enough points here to graph our line. Since we are graphing lines, we should see that these all should line up for us. If they don't, then that means that someplace we've made a mistake in our calculations, and you would have to go back to try to figure out where we made mistakes. Okay, we shouldn't get points that are all over the place. These should form a nice straight line. And if they do, then our last step is we can take a ruler. Okay, so nice and neatly line those points up, and then we connect those points with a straight line. I'm going to put an arrow on both ends showing to the reader that that line does continue forever. We've only calculated 5 points, but truly there is an infinite number of points that would be on this graph. We could put in every single nice value. We could also put in decimal values. You could sub in 1.5 and you'd be able to calculate that point right there. We could put in a really crazy number, like say 3.2875, and you would be subbing in an x value there, and that should calculate the corresponding y value there. We're just calculating 5 nice points that would allow us to graph this line easily. In my second equation then, I'm going to do the same thing. I'm going to set up this table. So I have my x and my y values. We can pick whatever x values we want. Now, we can use the same ones that we did here. The only thing I'm going to notice is that I need to multiply by 1/3. So if I try to do these values here, if I sub 2 in for x, I'm going to have 1/3 times 2, which doesn't really work very nicely. So if we are watching carefully here, whenever you have a coefficient on x that is a fraction, what we can do is pay attention to what that denominator is. So I'm going to pick things that will work nicely when I work with this denominator of 3. In other words, I'm going to pick multiples of 3. So instead of picking 2 and 1 and 0 and then the negative values here as well, what I'm going to pick here is, I'll still pick 0, but instead of picking 1, I'll use 3. That's a nice multiple of 3, and we'll see in a second that will work nicely here. And I'm going to pick 6, so another nice multiple of 3, and then on the negative side, I'll do the exact same thing. If I show the calculation, why did I pick those values? Well, if I now do 1/3 times 6 minus 2, this actually works quite nicely. Remember that when we multiply a fraction and a whole number together, that we can treat that 6 like it's over 1. So this becomes, if I multiply numerators and denominators together, I have 6/3, which works out quite nicely because that's actually 0. And if I sub in 3, I have 1/3 times 3 minus 2. 1/3 times 3 will give us 3/3, that's 1. Minus 2 is -1. If I do 1/3 times 0 minus 2, that works quite nicely. We end up with 0 minus 2. If I do 1/3 times -3 minus 2, again, that will give us -1 minus 2, gives us -3, and then 1/3 times -6 minus 2 gives us -2 minus 2 will give us -4. If you have a calculator that you can use efficiently to do some of this calculation work for you, if you're not comfortable with the fractions, I'm okay with that. You should be able to do this, but if you prefer to use your calculator, I am okay with that. Also, if you'd pick these numbers up here and put them down here, you would be able to use your calculator to get values here. The difference is, though, you would not get nice numbers here, you would get decimal values. It is not that it's wrong. You can go ahead and use those decimal values, but when you come over to graph, it's just going to be that much messier to try and graph those decimals. Not impossible, you can do it, but it just doesn't work as nicely. So if you think here, when you have a fraction, I'm going to look at the denominator and pick nice numbers to work with that fraction, then you get nice numbers here. If you miss it, okay, but then you're going to have decimals to plot. So if I now go ahead and plot these points, I have 6, 0. So remember x left and right first, so 6 and 0. There it is. I then have 3 and -1, so 1, 2, 3, and -1. There's my next point. 0 and -2, so not moving left or right, but going down 2. I then have -3, so to the left 3, and -3, down 3, and lastly -6, and then -4. So all 5 points just fit on the graph. If I connect our dots here, again, we end up with this nice straight line. And usually when we graph more than one line on one graph, we should label them. You can either label it clearly with the equation, or if there's some sort of indicator which line is which, you can also label it in that way. So I'm going to go back here and say, well, that was question A, and I'm going to label this one that this was question B. So there is using a table of values. Usually this is how we first show you how to graph lines, but this is a bit tedious to go through all these calculations. So if you remember from grade 9, we did take a closer look at these equations and we started to analyze, well, what do these numbers actually do? So the second and more efficient method, I would say, is what we call using the slope and y-intercept. On the side, I'm going to do a quick reminder that if I write the equation like we see here and in our first two examples here, we should hopefully remember that we had this here. We can write the equation of a line in this form called y equals mx plus b. And what we found is that these two values actually had specific meaning. This m value was called our slope, which was made up of two parts. There's a numerator, which we called the rise, and the denominator, which we called the run. And this b value, or the number on the end, was our y-intercept. So what we're going to do is now try to use these two values to now graph this a lot more efficiently than going through this whole table process. So if I look at this first equation here, I would have then, there is my m value, okay, or specifically I'm going to say there is my slope. So the slope is 2/3. And again, we said the slope as a fraction would be rise over run. And the value on the end would be our y-intercept. So the y-intercept in this case is -4. So to remember to use this information, the y-intercept gives us our starting point, saying on the y-axis we are going to intersect the y-axis at -4. So I am going to start my line at that point. Our slope then gives us direction. How do we get to the next point? And this is now broken up into two numbers. This is telling us that we will rise 2 and we will run 3. So from this point we are going to rise, so go up 2, and run. It's +3, so a positive run would mean go to the right. So positive, go up 2, positive, go right 3. And now we just use this pattern over again. From this point, how do I get to the next point? I just use that same pattern. I will rise 2 spots and I will run 3. There is the next point. We can actually use this pattern now backwards if we want to try to get more points as well. I can say, well, if I go back 3, I have to go down 2. If I go back 3, I have to go down 2. So if I go back 3, I have to go down 2. And there we get another point on our line. So very quickly and efficiently we can now generate points without having to go through all the work that we did up above. So connect those points. There is our line, and again we're going to graph a few of these, so I'm going to label that as our first line, or A. In our second one, same idea, but I just want to show you just a small twist here. Be careful because we see this negative sign here. Don't forget that means that the coefficient there is -1. We have our y-intercept, which is the number on the end, or the number that is not with the x, so our y-intercept is 5. So we can start this. There's our y-intercept up here at 5. Small twist, not only is it negative, but we don't have a denominator. So don't forget that we can always make any number into a fraction by writing it over 1. So there is our rise and our run for this graph. So we need to rise -1 and run +1. The negative stays attached to the numerator. So how do we rise negative? Well, like our Cartesian plane, where right is positive, left is negative, up is positive, down is negative, we do the same thing here. If I want to rise -1 from my starting point at 5, rise -1 means I actually come down. Notice though that the run still stays positive, so we will still go to the right. And from there, we just continue that same pattern. Rise -1, run 1. Rise -1, run 1. Rise -1, run 1. Rise -1, run 1. Notice we can very quickly generate a lot of points using this method, so we can actually graph a very accurate line very, very quickly by using this method here instead of making our table of values above. And again, we have a couple lines here. I'm going to squeeze that in there, that this is line B. Last question is the one that we need a little bit of work here. The issue is, in this equation, we are not in this y equals mx plus b form. Be really careful that we don't just start to try and yank numbers out to try and make this look like these here. This is not in that form. So my first step here is I actually need to get that y variable by itself. We can do this in 2 easy steps. Okay, if I want to get y by itself, I'm going to leave 2y here. My first step is I need to get rid of that 6x. In our last lesson, we talked about being able to rearrange equations, and we used the opposite operation. So if I want to get rid of 6x, then I'm going to subtract it on the other side. So I'm going to do 8 minus 6x. So to get rid of the 6x, we subtract it from this side, so I'll also subtract it from this side. So there it is. To get rid of this coefficient, we talked about the idea that we would divide as the opposite operation. The only difference here is now I have 2 terms on this side, so I'm going to divide both of those terms by 2. So every single term gets divided by 2. And I end up with y equals 4 minus 6x. We can leave it in that form. We just have to be really careful that we make sure that we know which one is the, sorry, not 6. Almost made a mistake. 3. I'm sure if we were in class, somebody would point that out to me. Okay, make sure we're dividing. So 6 divided by 2 gives us 3x. We can leave it in this order, or some students like to rearrange it so that it looks identical to this here, where I get negative 3x and positive 4. Just be really careful that that sign goes with that and the positive goes with this term. When we do that, then now we're back to what we were doing here. So we can very quickly see then that our slope is equal to negative 3. We want to write it as a fraction. Reviewing that from here, we can write that over 1. And we have our y-intercept, which is 4. So we can take that information now and quickly graph our y-intercept. There it is at 4. We're going to rise negative 3 this time, so go down 3, run positive 1. Rise negative 3, run positive 1. Rise negative 3, run positive 1. So we very quickly generate a whole lot of points. Okay. Connect those dots. And there is our third line, and I'll label that down here as C. Again, if you have any questions, don't hesitate to send me a message or join into our Google Meet, and I can help you there. Have a good day, everyone.